Let's talk a little bit about image compression. So if we were to deal with an image like this, the flag of Germany, at its most basic level, we are going to, if we are using raster graphics, bitmapped graphics, we are mapping a color with bits to each little square on the image, right? So if we were to zoom into this image, we would see that there are a bunch of squares. I'm trying to zoom in, it's not working. Let's see if I actually click it, what happens. Germany, and zoom in, there we go. If we were to zoom in on this image, we would see that this image is made up of a bunch of squares, a bunch of little squares of color, right? And get back to 100% here, there we go. And so each square of color, we would need to maintain that information, right? Like what color goes in this square, what color goes in the next square, what color goes in the next square, and then we do that all the way across this image. And if we were to use 8 bits per square, and this image is 800 by, or this image full resolution is 1000 by 600, 1000 by 600 pixels. So if we had an image that was 1000 pixels wide by 600 pixels, and we used 8 bits for each pixel, each picture element, that means we are storing 4.8 million single zeros and ones. And that would be, right, 4.8 single zeros and ones. And so that's bits. We divide by 8, that gives us bytes. So let's put that there. And if we divide by 1,000, that gives us kilobytes, and we divide by one more 1,000, gives us megabytes. So that would be 0.6 megabytes. Not that bad, right? But it's 4.8 million zeros or ones to store the information of this flag. If that flag is 1,000 pixels wide, 600 pixels tall, and we're using 8 bits per every pixel. If we do it at 16 bits, right, that doubles. And if we do it at 24 bits, it goes up again. And so here we have 14 million single zeros and ones if we're using 24 zeros and ones for each little picture element, each pixel. Why would we want to use 24 million zeros and ones? Well, that would allow each pixel to be one of, incredible amount of colors. Because if we're using 8 bits, each pixel can only be one of 256 different colors. But if we're using 16 bits, then it's like millions of colors that each pixel could potentially be, right? Because coding schemes and all of that. And this arrangement of zeros and ones equals this shade of color, and the next arrangement of zeros and ones equals this shade of colors. But when it's 8-bit, you're limited to colors, and so you don't get as good of gradations. So when we're talking about an image like this, we would probably stick to, lower bits per pixel, like 8 bits, the bit depth. That's the word. The bit depth would be like 8 bits. And, that, because we just need black, we just need red, and we just need yellow. That's it. But we're still storing information for each pixel in this image, right? We're mapping the bits to each pixel. So how can we compress this image so we store less information about it? So the way compression works is we could come up with our own formulas, our own algorithms for saving image information. And is there another way to save this information? And yes, absolutely there is. So mathematically, if we looked at this as a grid, right, with the y-axis and the x-axis, and we could say, okay, from this point on the grid to that point on the grid, everything's yellow. From this point on the grid to that point on the grid, everything's red. From this point on the grid to that point on the grid, everything is black. And so we could write some little algorithm that just says, from this point to that point, all black. Right? And now we're storing a lot less information. However, to read that file format, computers would then need to understand our file extension, right? Our file extension. So if it's, whatever file extension, it needs to know how to unpack that information and basically take that information and turn it into an image. And so that's how compression would work, right? We went from this image where we are mapping each bit, and then we created some little compression algorithm, a file format, which looked at this image and then came up with a mathematical formula for storing the color information without having to store every single little pixel, what the color is in every single little pixel. And so that's kind of like an introduction to compression and how compression works. How would you do it for this one? Same way, right? French flag from here to there, blue. From here to there, white. From here to there, red. Same kind of way. All right, so that's an introduction to compression.